Hello students, standard 7. Today we are going to start the new chapter, chapter number 9, rational numbers. Before we start the rational numbers, let us revise our knowledge about the numbers. In the beginning, we know the numbers which are known as natural numbers or counting numbers. We start from 1. When we count the things, we count like 1, 2, 3, 4, 5. So that 1, 2, 3, 4, 5 and so on, they are known as natural numbers. Then we include 0 with the natural numbers. Then the whole collection from 0, 1, 2, 3 and so on, they are known as whole numbers. Now, after the whole numbers, sometimes we saw that in subtraction, sometimes we do not get answer. When we subtract smaller number from greater, then we get answer. But when we subtract greater number from the smaller number, like 3 minus 7, we don't get answer. So in this situation, they include more numbers which are the opposite numbers of the natural numbers, negative numbers, like minus 1, minus 2, minus 3 and so on. So the whole numbers along with this negative numbers, the whole collection, that is known as integers, in which 1, 2, 3, 4, etc. They are positive integers. Minus 1, minus 2, minus 3, etc. They are negative integers. While 0 is neither positive nor a negative integer. It's a neutral number. So these numbers are familiar for us. But now sometimes you see that not always the numbers are in the form of integers, because sometimes we use the fractions also, means the part of the whole. For example, sometimes we need to distance, we need to represent the distance which is not exactly in the full kilometers, but a fraction of full kilometer. In this situation, we can't express them as an integer. In this situation, we use the fractions or the fractional number, because it is not possible to express them as integers. For example, here it is written that 750 meter above the sea level. Now it is in meters, but if we want to convert into kilometer, then when we simplify it becomes 3 by 4. Now 3 by 4 is not an integer. In this situation, we use the fractions also. So in this situation, we need to extend our number system so that we can include that type of numbers like 3 by 4, 7 upon 5, 9 upon 2, etc. And then the idea of rational number came into existence, because we need this type of numbers in so many situations in our life. Now this word rational numbers. So rational, that word derived from the term ratio. We know that ratio like 2:3, 4:5 we write down like 2:3, that is the ratio. So then ratio can be written as 2/3. 2:3 is written as 2/3. So here it is from the ratio we write down the number. So it is known as rational numbers. So now what is actually are the natural numbers? What are the natural numbers? So here there is a definition of rational numbers, that a number that can be expressed in the form of P upon Q, where P and Q are integers and Q is not equal to 0, is called a rational number. It means that when a number can be expressed as the form of P upon Q, but there is some condition. Condition is that P and Q are integers. Integer means it can be 0, but only Q cannot be 0. P and Q are integers. Means that can be positive integers, that can be negative integers. P can be 0 also, but Q cannot be 0. So, if you can express any number in the form of this type P upon Q, where P and Q are integers but Q is not equal to 0, it means that in the place of Q we cannot place 0. Any number except 0. And in the place of P you can put any integer. It can be 0, it can be positive, or it can be a negative integer also. For example, you can see here 3 upon 4, minus 2 upon 5, 7 upon 9, etc. All are rational numbers. So, all fractions are rational numbers. As we saw that fractions, we learn about the fractions. And then these all fractions are also rational numbers. Now, why? Because we can write down them in the P by Q form, right? So therefore, doesn't matter it is which type of fraction, right? So we can write down them in the form of P upon Q. It can be a mixed fraction also, but we know how to convert that mixed fraction into improper fraction. So proper fractions, improper fractions, or the mixed fraction, all can be converted in the form of P by Q. And it fulfills these conditions, and therefore all the fractional numbers are also rational numbers. What about the decimal number? Like 0.7, 5.9, 3.8, etc. We know how to convert them into normal fractions. Like 0.7, we can write down as 7 upon 10. If it is 3.25, then you write down 325 upon 100. You already know about it. So that is the form of P by Q. Here 0.7 written as 7 upon 10. So what is this? P by Q form, same type like. And therefore the decimal numbers are also fractional numbers. So any integer can be thought of as a rational number. Any integer. Why integer? Integer like 7 or 9 or 15. Where is the Q? But we know that when there is no denominator, what do we put as? 1. So 17 can be written as 17 upon 1. 15 can be written as 15 upon 1. It means that all the integers, minus 9 also, minus 9 upon 1, minus 9 upon minus 8 upon 1, etc. So here all the integers are also can be thought of as rational numbers, as we can put 1 here. We can put 1 down, 7 upon 1. So 7 is also a rational number. Now in rational number p by q, p is known as numerator, same like in the fractions. So p is known as numerator and q is known as denominator. And as we saw that 0, what about 0? Is 0 a rational number? Yes, because 0 is also a rational number, as 0 can be written as 0 upon 1. So in any integer, when we put 1 in the denominator, then what happens? It becomes a rational number because it converts in the form of p upon q. It means that the rational numbers include integers and fractions. Doesn't matter they are positive or negative or 0. All the integers, all the fractions, including that all fractions of normal fractions, like proper fractions, improper fractions, mixed fractions, and the decimal numbers, all can be thought of as rational numbers. So these rational numbers include integers and fractions also. Now we have to understand about the equivalent rational numbers. Equivalent. The word suggests you what is the meaning of it. It means they are equal. So when we multiply, if the numerator and denominator of a rational number are multiplied or divided by a non-zero integer, we get a rational number which is known as equivalent rational numbers of the given rational numbers. It means that if a rational number is given and we need to find an equivalent rational numbers of that number, then what should we do? We have to multiply or divide the numerator and denominator with the same non-zero integer. We cannot multiply with 0. Except 0, we can multiply or divide the given fractional, rational number. Then we get another rational numbers. And that new number and the original number, they are equivalent rational numbers. For example, look here, 4 upon 3. You multiply 4 upon 3 by 2 upon 2. 4 multiplied by 2 and 3 multiplied by 2. So what do you get? 4 2 is 8, 3 2 is 6. So here 4 upon 3 and 8 upon 6, they have the same value and therefore they are known as equivalent rational numbers. So here in equivalent rational numbers, we can not only multiply, but if there are big numbers and they have common factors in the numerator and denominator. For example, if you go reverse, 8 upon 6, for example, 8 upon 6. So we can divide 8 divided by 2 upon 6 divided by 2. So 8 divided by 2 is 4, 6 divided by 2 3. So we can do the division also. So either we can multiply or divide, but you have to remember that thing, that when you multiply or divide, the both numerator and denominator must be multiplied or divided by the same integer, and it should not be 0. 2 and 2, 3 upon 3, 7, 7, 9, 9, whatever is there, but same number should be there in the numerator and in the denominator. So it is same like the equivalent fractions. We learn about the equivalent fractions also. So the equivalent fraction and the equivalent rational numbers are the same thing. But as I told you, you have to remember. What you have to remember? That when we find rational numbers which are equivalent to given rational numbers, then if you multiply the numerator and denominator, it should be the same number. And if you divide the numerator and denominator, then it will be also the same number. And then the both answer, when you get it, then they are known as the equivalent rational numbers. So I hope the idea of this equivalent rational numbers will be clear in your mind. So what did we learn today? Just revise today and then we will finish our video. First we saw that rational numbers. Why we need rational numbers? Because some numbers that cannot be expressed as an integer. In this situation, when the part of some whole like kilometers into meters and meters to kilometer, rupees and paise and so many other things are such that sometimes they cannot be expressed as the integers. In this situation, we need the another numbers. So we include in the integer the fractions also, and then it can be written in the form of P upon Q. And as I told you, P can be any number. P can be positive, P can be negative, or it can be 0 also. But condition is that Q is not equal to 0. It means that if you write down 7 upon 0, it is not a rational number. Why? Because our condition that Q should not be 0. Q never can be 0. 0 upon 7 can be a fraction, rational number. Because P can be 0 or positive or negative. But Q must be either positive or negative but cannot be 0. And then we saw that all the integers in the denominator we can put 1. Therefore all the integers are also fractional numbers. Also the decimal numbers and so on. So here P is known as numerator, Q is known as denominator, and then we learn how to find the equivalent rational numbers. So here we are going to finish the today's session, and it will be followed by the PDF. And any confusion, write down in the comment section. Thank you very much.